Hello and welcome to this video about the Liskov Substitution Principle in C#, one of the fundamental principles in object-oriented software design. The Liskov Substitution Principle, or LSP for short, is part of the solid design principles, and it helps to ensure that software is flexible, maintainable, and robust. In this video, we'll take a closer look at what the Liskov Substitution Principle is, why it's important, and how you can apply it in your own C# projects. The Liskov Substitution Principle is named after Barbara Liskov, a computer scientist who formulated the principle in 1987. The principle states that if you have a base class and a derived class, you should be able to use objects of the derived class in place of objects of the base class without affecting the correctness of the program. In other words, a derived class should be substitutable for its base class without breaking the behavior of the program. Why is the Liskov Substitution Principle important? The Liskov Substitution Principle is important for several reasons. First, it helps to ensure that software is flexible and maintainable. By designing software with LSP in mind, you can easily add new derived classes without affecting the behavior of the program. Second, LSP helps to ensure that software is robust and reliable. If you violate LSP, you may introduce unexpected behavior or bugs into your program. Finally, LSP is important for software reuse. By designing software with LSP in mind, you can easily reuse existing code and avoid writing duplicate code. In this example, we have the square and shape classes. The violation of LSP occurs because the square class does not behave consistently with the rectangle class, despite the fact that it inherits from the rectangle class. Specifically, the square class overrides the setWidth and setHeight methods to set both properties to the same value, which violates the behavior of the rectangle class. This inconsistency causes problems when the square class is used in place of the rectangle class in certain situations, such as when calculating the area of a group of shapes. While a rectangle object can have its width and height set independently, a square object requires that its side length be set to the same value for both width and height. This inconsistency causes issues when trying to perform calculations that assume all shapes behave consistently, such as when calculating the total area of a group of shapes. By violating the Liskov Substitution Principle, we introduce these inconsistencies and dependencies between classes, which can lead to unexpected behavior and errors in our programs. So how can you apply the Liskov Substitution Principle in your own C# software development projects? Here are a few tips. Define clear and consistent interfaces for your base classes and derived classes. Make sure that derived classes can be substituted for their base classes without affecting the correctness of the program. Avoid using inheritance to change the behavior of a base class. Instead, use interfaces, abstract. One solution to this violation is to remove the inheritance relationship between the square and rectangle classes altogether, and instead create a new quadrilateral class that both the square and rectangle classes inherit from. This new base class can define the common properties and behavior of all quadrilateral shapes, while the square and rectangle classes can define their own unique properties and behavior. With this solution, both the square and rectangle classes can be used interchangeably with the quadrilateral base class, and the behavior of the program will not be affected. Additionally, we have removed the violation of LSP by no longer assuming that a square is always a special kind of rectangle. In conclusion, the Liskov Substitution Principle is an important concept in object-oriented software design, and it helps to ensure that software is flexible, maintainable, and robust. By designing software with LSP in mind, you can easily add new derived classes, reuse existing code, and avoid introducing unexpected behavior or bugs into your program. Remember to define clear and consistent interfaces for your base classes and derived classes, and make sure that derived classes can be substituted for their base classes without affecting the correctness of the program. By applying these principles, you can create high-quality, reliable software that is easy to maintain and extend. Thanks for watching.